So unfortunately, in the time that I put this talk together, I didn't have opportunity to dive into LIMBO too much with other people, and it really does require other people. It's not a by-yourself thing. So I want to change the title of the talk a little bit and take out LIMBO. And since I'm not going to anywhere, that doesn't make sense to have the to in there if I'm not going to anywhere. The from doesn't make sense. So I'm just left with test and commit or revert. But what I ended up doing was talking about patterns a whole lot, software patterns, design patterns, architecture patterns. And so we're going to add that in there and then finally do a little bit of formatting. So here's the title of the talk on patterns and test and commit or revert. My name is Shane Becker. I go by Vegan Straight Edge on the internet. I look like this in most places. I used to look like that, and that. I normally wear a Cubs hat, and me and Terrence Lee are sort of the blue hat Ruby crew. I once co-organized Cascadia Ruby with Ben Blything in Seattle, and then after me, they did it in Portland. I put on the best backyard storytelling conference in the universe called RailsConf in Hollywood, California. And I used to be the open source cheerleader for Engine Yard way back when they were a company. And I worked with the open source teams on Rubinius and JRuby doing sort of community outreach kind of stuff. I currently live in a small town called San Francisco, California. And I work for a company called Mode. It's also on my hoodie here. It's totally amazing. The culture is really great. These are the company values that you can't read at this size, but if you talk to me or CTO or a coworker, we will tell you them. We have lots of inside jokes about goats and lots of puns, all of the puns. The people are great. We have developers and engineers at various experience levels and interests and expertise. And of course, we're hiring. You can find more about the company at mode.com. The product is, let's imagine you have some mountain of data in a database and you want to ask data-driven questions or get data-driven answers. You could, if you have data scientists, data analysts, or just curious folks who are willing to write a little bit of SQL or already know SQL, they could do the thing. Sincerely, you should click. Go find our CTO, who is somewhere in this room, and we'll be at the table out in the place where the tables are. She is the very best. You should go find her and come work for us. Okay, on to the talk. The talk is going to be 3 parts. A sort of technical overview briefly of what is test and commit or revert. And then this weird, wild, and hopefully wonderful historical interlude. Does everyone know that they're in a talk on this track called Weird, Wild, and Wonderful? Okay, great. So that's what you're in store for, I hope. That's what I set out to have you in store for. And then toward the end, some more sort of deeper dive into the technical stuff, the lessons I learned in the process. Can you start the countdown clock? The big red one, thanks. Okay, so here is the TLDR for the whole sort of technical part of the talk. It's actually right in the title, test and commit or revert. So it's just right there. And for the people in the back, I made it big. So let's break this down, right? Because these aren't actually like Unix commands that you can issue, right? Test isn't a thing. So these are just ideas, these are concepts. So let's turn these concepts into actual commands we can issue, right? So test, maybe you're running mini-test and you could use rake test, or maybe you're using RSpec, and maybe that RSpec has to be run under the context of bundler, and maybe you have an alias because you hate typing like I do. Okay. So that's the test part, right? And then the commit part in test and commit or revert means like commit all of the things. You're not going to be picky. You're not going to choose some things. You're going to commit everything. And so we could do a git commit -am all of the things. And if you don't know the -a or the -m means I'm going to have a commit message in line right here in this command instead of popping open my editor and typing a thing there. And -a means add all of it. It's the equivalent of doing a git add dot, but only of the files that you already have tracked under version control. So in Bash, you don't have to have quotes around things if they're single words, so we'll just say working. And to do our future selves a little favor, we'll use something that's sort of a signal to what the hell is this weird little small commit. Okay, and again, -A doesn't catch untracked files, so if you create a new one, it won't show up in that commit, so I'm also going to tack on a git add dot, which leaves us git add dot and git commit -am tcr for the commit part of test and commit or revert. And now the revert is the opposite when you want to undo all that work. And chances are you're using Git. If you're still using Subversion, I'm sorry, come in from the cold. We have hot chocolate, we have central heating. But to be clear, it's not a Git revert in the sense that you're undoing a past commit. It's undoing all of my unsaved changes, okay? And there's two ways to do this in Git, at least two ways. You could do a git reset -- hard, which is bold and daring, and that's gone forever. Or you could do add all your files, make sure you have untracked ones, and then you could stash it. And the stash is like a, what is it? Last in, first out stack. So you could catch those changes back out if you want to. But for our purposes, we're going to be bold and daring and let go of the past. So we went from this, test and commit or revert, to this, which I will never type by hand. So I made an alias because I hate typing, and it's just TCR. And now that it's just one little word, we can make it really big, and that's easier to see in this very large room. Okay, so if you're only here for the sort of like technical reenactment, or the reenactment of a technical blog post, thank you for attending my TED Talk. You're free to go. Because now I want to talk about like the idea of TCR and like where do ideas come from, man? Okay, so I'm already tired of saying test and commit or revert, so I want you to create a mental alias for when I say TCR, I mean test and commit or revert. So what the hell is this thing? In my opinion, TCR is 5 things. It's just an idea. Which I have opinions about that word just. I think we should all we should just purge it from our language. It's just an idea, right? It's not a prescription of particular tools or technology, right? It's a combination of things that we already know. I bet everyone in this room has run tests, maybe written tests, has committed code, and has reverted code. It's also the automation of that combination. So we do all these things together as one thought. And then it's also naming the pattern of that combination and automation. And then finally, maybe it is a new way of doing software development. We'll see. I don't know. It's still like, it's not even in its infancy. It's like a zygote of an idea still. It's super new, unclear its future. So if TCR is quote unquote just an idea, like why now? Why didn't someone else come up with this before? And to speak to those questions, I'm going to tell the history of TCR, or rather like a history of TCR, because let's start with the true facts that no history is objective or complete or unbiased, or the reverse of that. So we could say that this section of my talk is a brief and incomplete history of people, events, and ideas that predate the idea of TCR, which, when swirled into a stew and looked at through a particular perspective, might be seen as like related around a particular theme or something. Okay. So, the middle act, right? I'm going to put a bunch of pins on a board and draw lines or connect them with yarn, and hopefully there will be like a thematic connection, and that sort of mosaic will make some sort of sense at the end. Okay. I'm going to tell this history of these things that ultimately lead to me in this moment giving that talk right there. Okay. So where do we start? Unless you start at the Big Bang and include every single thing, every history has some chosen, curated start. I wanted to start this 100 years ago when Eisenhower took a road trip from DC to San Francisco, and it took 62 days, but it got cut. So let's start in Eugene, Oregon, at the University of Oregon in 1961, when the university published its quote-unquote master plan. This is not it. This is like a Apple Maps picture, but that is the, let's see, does that thing work? Yeah. That is the University of Oregon campus. And on this master plan, where they laid out decades of architectural development, in the sort of like ultimate Gantt chart and waterfall development, they laid out that they wanted to destroy or like raise this 1800s cemetery and build some buildings. People, the members of the community, students, faculty, and staff, they resisted this idea, they pushed back, and they were able to stop it. And then in 1968, the university created a new building for the science department called Klamath Hall. And Klamath Hall was a building that is ugly. And it is in a style of architecture called brutalist or brutalism. And if anyone in this room doesn't know about brutalism, it's worth a quick side quest, which is these buildings tend to have a lot of concrete involved. They tend to have a lot of sort of rigid geometry. And in some ways, they had their boom in the like 60s and 70s. And in some ways, these buildings remind me of the Jetsons. It's this like retro neo-futurism. It's like our parents or grandparents' vision of what they thought the future would be, and it's a future that never really happened. So there are these like artifacts or these relics. And every time I think of of brutalism, I always think of this one building in particular that's now abandoned and was created as a sort of Soviet monument in Bulgaria, which is in that part of the world. If I was John Oliver, I would show like a picture of like South America and say there, and then switch. And this place is named this. I don't speak Bulgarian or Turkish, so I don't know how to pronounce that. My apologies. I have read that it's Turkish for icy, which makes sense because it looks like Hoth. But to me, this building makes sense. This like weirdly, like in this place, like on the peak of this hill, even like at like off in the distance, like its silhouette makes sense in this context. And in a way, it's like even kind of beautiful. Admittedly, like for me, part of the beauty is that it's abandoned and falling apart. I think that's kind of pretty in its own way. And in the right context, these buildings can be really beautiful and even kind of cool and hopeful. But in the wrong context or done poorly, this is the Buffalo, New York City Court building. Imagine going to work there every day. There's not a single fucking window. Or like this building looks like a goddamn battleship. So I mostly don't like brutalism, but I could see it done well sometimes. So back to Klamath Hall, it was none of those things. So it was ugly, or is. This building is still there. It is ugly. It is out of place. The rest of the building is like, or the rest of the campus is like red brick and trees and, you know, like the Pacific Northwest, right? And it's frankly pretty inhumane. And then in 1970, brace yourself, this gets a little dark for a moment. In the Pacific Northwest, there's a lot of logging, clear cuts, and those logging trucks would sometimes drive through the campus, and in 1970, one of those logging trucks killed a student. And so, rightly so, people were upset, and a combination of that happening, it was just sort of a general time of unrest and protest, and these like development decisions, the community was like, you know, we want to have some, we don't like these particular decisions, but we also don't like the process in which these decisions were made. So the president of the university enlists a group of architects from UC Berkeley, and these are their names. I will refer to them as the Christopher Alexander Group later. They come in and they're asked to like basically solve their problems. So one of their problems is which buildings to build. And the other problem is, how do we decide which buildings to build? So they write this all up and publish it in a book called The Oricon Experiment. Everyone in this room should read this book. It's, you know, half-inch thick, 180 pages, you know, pretty small. And it lays out these 6 principles. Organic order, meaning like the whole is only ever presented by a bunch of local acts. You can't build the whole. You can't build the web. The web can only be expressed by a bunch of websites. Participation, the users of a space, you know, the faculty, the students, the staff, must be the ones to decide what to build and when to build it. Piecemeal growth, right? Small iterations. Patterns, this part was huge. Patterns is an agreed upon sort of vocabulary which we build from, we design from. Diagnosis and coordination. So all those get published into this book. Again, everyone should read it. They also published The Timeless Way of Building, which laid out the theory of this process. And then A Pattern Language, which is a tome. It's the best of these books. It lays out 250 patterns, some of which are very large, like neighborhoods should be identifiable, right? And there should be an eccentric nucleus, so on. And then some very small, like there should be sitting walls. Here are different kinds of sitting walls, right? So it's this broad scope of things. Okay, so how do we go from there to here? Thank you for bearing with me. Here's where we turn towards making computers go. So just like how two people at the same time in Europe discovered calculus independent of each other, in 1979, that didn't happen in 1979. That'd be weird. In the year I was born, in 1979, two different people read a pattern language and came to the same sort of revelation, independent of each other, and wouldn't meet for years later. So one of them was named Ward Cunningham. I wasn't able to talk to Ward directly for this, but other people told me he was given a draft copy of a pattern language. And then Kent Beck was always just like really into architecture as a kid and still. And so he read this book in the U of O bookstore, like an hour at a time, standing up in the aisle because he couldn't afford to buy it. And then several years later, in 1985, Kent Beck happens to get hired onto a project that Ward Cunningham is already on. And in the process, they accidentally invent or rediscover pair programming. And then they start talking about pattern language, patterns in general, and the ideas they've had as this connection between how buildings can be built in this process and then how we're building software. So they launch a website called the Portland Pattern Repository, which is hosted at c2.com, and it is the first wiki. Ward Cunningham created it for this site. It's still there. In 1994, the sort of continuation of that community eventually publishes a book called Design Patterns by a group of authors that get referred to as the Gang of Four. This is one of the seminal texts in our industry. A few years later, in 1997, Kent Beck published a book about patterns and small talk. And this is the book that kicked off the whole thing that led me to talking today. I was borrowing this book from a coworker and friend named Josh Susser, and a couple of chapters in, I was like, oh, patterns. I remember a book called A Pattern Language. It's been recommended to me in like the late 90s when I was making Flash websites as some like metaphor for web design, and I read it thinking, this will be a web design book, and it's not. It's literally about building buildings. I thought that would be like a metaphor for building websites. It wasn't. So I wasn't ready for it. And then later on, a friend recommended it because I want to build a tiny house. And again, I just wasn't ready for it. This time I bought it sort of sight unseen, and I got it. This book, there's a direct through line from this book published in the 70s to this book published in the late 90s. Okay. And I made this connection independently. But it was in the context of the 4 decades of like the influence that these other people and their connections that they had made has influenced our industry and the way we do work. All right, so Kent Beck is also credited with inventing test-driven development, or TDD, but the way he explained it to me is he rediscovered TDD. In the 60s, NASA was actually doing TDD during the Mercury missions. They would write out input tables, back when we had input tables, and output tables, and just write code until it matched. That's TDD. Extreme programming basically falls out of this from Kent Beck as well, combining some of these tools. So pair programming, TDD, story cards. And shortly thereafter, we get the most beautiful website ever, the Agile Manifesto, which is just frozen in time. And this giant image tiles, by the way. If you scroll down, there's just the same image over and over. All of the ideas in Agile come directly from these books, okay? Especially the Oricon Experiment and its 6 principles, the first 3 of which describe Agile development. Okay, so how do we go from architecture design principles in the 70s to testing, commit, or revert in 2018? And my hunch is that there's a few people sort of hovering around this idea at the same time. There's a few actors. So Kent Beck had for a long time been doing test and commit as sort of one thought, just sort of out of laziness and efficiency and just habit. Okay. And then in 2012, Sandy Metz publishes this book, which you should all read. And if you haven't, or if you have read, reread it. It's so fucking good. Colloquially, it's referred to as pooter, as like a little kid would say computer. She covers like refactoring and patterns and design and testing. Timeout here. I'm confused. That says I have 20 minutes left, and this says I have 39 minutes left. That cannot be right. I have not been talking for 1 minute. That's some fast talking. Okay, so in 2017, Sandy and Katrina Owen published this book called 99 Bottles of Oop, where you program either 99 bottles of beer on the wall or milk on the wall. It is also great. Everyone should buy this book and read it. And in this process, in the book, they describe the process of basically like manual TCR. They say, make a tiny change, run the test. If they pass, commit. If they don't, undo your change, make a better change. That sounds like TCR. Or the other way around, when I learned about TCR, I was like, that sounds like 99 bottles of OOP. And it's worth pointing out that Kent Beck wasn't even the one that came up with the or revert part. That was at in Oslo at Code Camp. He described his process of doing test and commit, and then this person, we'll say Oddman Stromer, said to him, well, if you do this, then logically you have to do that. He saw the symmetry. And Kent Beck was like, that's absurd, but it's cheap and it's safe, so we must try it. So who invented TCR? I don't know if that's the right question. I think attribution is important. People should not be lost. People should not be like written out of history. But maybe the question is like, who discovered TCR? Maybe it was Katrina Owen because she described manual TCR and she was doing it. And maybe it was Kent Beck because he named the thing. And maybe it's Oddman because he tacked on that last part. Who knows? But I think the real point is that ideas don't exist in a vacuum, and they're also not created in a vacuum, right? We never ever have like eureka moments. We always have like the next. Right? So every idea stands on the shoulders of giants because everything is a remix. If you haven't seen that video series, you should. Led Zeppelin did not write original music. That's fine, but everything is a remix. And since everything is a remix, this is also an idea that you should go read about. We have basically the same brain as our Paleolithic ancestors. But they could not have imagined nuclear missiles. They could imagine rocks, and then rocks attached to sticks, and sticks that are so on. So one of the things Sandy said to me is that maybe the idea's time had just come, right? The idea for TCR was just in the air, and if one of these people didn't come up with it, someone would have. Maybe someone in this room. Okay. So now we're into that third section of the talk. We're done with the sort of like historical interlude of conspiracy theory. Okay, so in my like early misadventures into TCR, here are some things that I learned. Improving tests, if you're not changing any implementation, TCR is great. Because as long as, like your goal here is to change tests and have them keep passing. So every change you make that passes, commit that fucker. If they don't, you don't want that. And there's a lot of like sunk cost fallacy feelings in this. But when you throw something out that doesn't work, you're throwing out something bad. You're not throwing out something good. Okay? But if your test suite does not run in just like a few seconds, it behooves you to not run the whole test suite, right? So you could run an isolated test, just the ones that have a change in them, which gives you a much faster feedback loop, which, is super important. If the feedback loop is longer than a few seconds, TCR feels clumsy. So the takeaway is like make your tests fast, and that's sort of hand-wavy and reductive, but you could make your tests fast by making your tests fast, or you could run isolated tests manually, right? So you're editing either that alias or your manual kind of like typed out version of TCR. Or you could run isolated tests automatically. And I think some of the tools that we have at our disposal can do the right thing here. I think RSpec and Minitest and Guard, you could say like just run the test localized to the change that I made. Okay, so fast tests are super important here. And the place where TCR is like obviously a good idea is refactoring, because using the sort of Martin Fowler definition of refactoring, of changing internal arrangement of your code without changing the external behavior of your code, it's perfect, right? You want to move stuff around, reorganize your code, but not break your test. So make a tiny change, run the test. If they pass, commit. If they don't, undo, and then repeat. OK, so I did a few pairing sessions. Pardon me here. I'm going to take a little drink. Remember when Mark Rubio did that that State of the Union rebuttal, and he was just pounding water? So a bear walks into a bar, and the bartender says, "What can I get you?" And he says, "Gin and tonic." OK, so the first pairing session was with Morgan Fogarty, and we built Fibonacci, right? It's like a known little domain. And here are the things we learned. The commit history is completely not useful, OK? It's that, every single one of your commits. And then so it's like, does that matter? Is our commit log important? It feels like yes. I feel like I go back and read it sometimes. But I never went back and read my old issues of comics, but I liked having them. So maybe it's something like that. So maybe we should always work on a branch, which most of us do most of the time anyhow, and never work on master. And then when you merge your PR, you could do a squash commit, take all that noise out of your commit history. That's probably also a good idea, even if you're not doing useless commits or useless messages. We also found that we had a reflex to want to just undo our changes that we lost to the or revert part. And we asked, is that cheating? What is cheating even in this situation? So, but we moved on. And we also were sometimes confused by, we'd get a failure or an error message, and it would refer to a line of code that was no longer true. So it'd be line 7 puts foobar, and we'd go to there, and puts foobar wasn't there anymore. So that was sometimes confusing. But that could probably be solved by tooling, not by removing the idea itself. Maybe there's TCR tooling that sort of captures some state of what the failure was and shows you that. We also found that it was tricky sometimes to make changes to both the test and the implementation. Basically, it's the opposite of TDD, right? So TDD says red, green, refactor. You write a failing test, but TCR says if you write a failing test, that failing test gets reverted. So a sort of trick workaround, again, is this cheating? Unknown. We would write a test, and then we would hard code the implementation. We expect foo to return 37. We would just go put a 37 in foo as the return value. We'd run TCR, the test would pass, which would commit, which would lock in that test. And then we could go TCR on just that implementation. With the, those changes could be reverted over and over, but we wouldn't lose our test. OK. And the bear says, "I'm a bear. I got him from my mom." Because he has big paws. So the reason that joke is funny is because a bear would never go into a bar and order a drink. A bear drinks at the campsite. OK, so I paired with Evan Phoenix on an actual production bug in Puma. Does anyone not know what Puma is in here? Great, you're all probably using Puma. This was a totally inconsequential bug. When you start it, the output in the terminal would tell you what port it's running on. Even though it was running on 3000, it always said 0. So like, cool, let's go do this. And we did it over the course of 6 commits in 2 files, and we got about a dozen reverts. And most of those reverts, do y'all know the tattoo that someone got that said no regrets? That's what I always think of when I'm going through this. So mostly those reverts were when we were sort of exploring the interface of the TCP class or module. It's this old, murky place. And we ended up needing .string, but obviously we thought we needed .2s. And .2s was giving us this string of hex, not 0. So this is what our commits ended up looking like. Super helpful. And we were running isolated tests for speed because Puma is all sort of network tests because it's a web server. And then before we did our pull request, we would run the entire test suite and then again in CI. And that worked out really well. That was maybe a half hour or so. And that was a new feature, which was, I'm sorry, I left something out. So the first test that we wrote was a test that succeeded by describing the buggy behavior. And then from that test, we could then change our expectation of that feature and then go fix the implementation. So I paired with Bookisworthy on a Rails and React app just on the Rails side. It's called Kids on 45th. It is this website. It's like cheap clothes for kids, and it's like Stitch Fix for kids. And oh my God, the tests were so fast. We could run the whole suite every time. And over the course of 86 minutes, we did 53 commits. And one of the things we kind of accidentally discovered is if you wanted to, if you were like a contractor or someone that had to keep track of their time, you could use your commit log to do it. Because way down here at the bottom, it says 86 minutes ago, and then way up here at the top, it says 3 minutes ago. And we normally only capture the last thing, when we did the save or the commit. So that's certainly not the reason to do this, but that's a fun little side discovery. And it really kind of encouraged us to make these really small moves, right? Even 2 lines was sometimes too much because, oh fuck, we have to retype 2 lines. And we started making single character moves. So we would write, this kind of change, like a setup in our test. Because update, when it fails really quietly. And we'd run TCR, it would succeed even though update errored or didn't validate. And then we would add the bang, and then update bang fails very loudly. So we would then get a failure, it would get reverted, but we only lost 1 character. And suddenly we cared about how much we had to type. So by being very careful, we learned that we could be very risky. And so the big takeaway is small moves. Why are small moves important though? Why are they good? We talk about them all the time, small objects, small methods. But what do small moves actually give us, right? So small things are safe, they're easy, they're cheap to try, but more importantly, they're cheap to fail. Because pause is a homonym with pause, like bare feet. The amount of time. Okay. So we also, like Morgan and I, we had this inclination to undo, or he was using Vim and it didn't auto refresh the file. And so we were like, oh, we could just resave the file, and then we didn't lose our changes, but we're doing this to do this, let's find out. And so we were like, let's trust the process and be really pedantic and feel the pain of losing changes so that it would encourage us to find the benefits. And the benefits were, make small moves, sometimes single words, sometimes single characters. And we also found that we could really go do some exploratory demolition and let the or revert clean up for us. We didn't have to keep track of where all of our puts is and our I think it's foo.bar, but it turned out to be foo.baz. If it fails, it just all gets cleaned up for us and we can start fresh every time. So sometimes just exploring some class we don't know well or some method. And we would just go put it into our implementation that our test is testing, and then this would not succeed, and then it would go get wiped out for us. So it gave us additional points to put tests onto without having to spin up a whole test. We also found that writing things outside in was, again, safe, which allowed us to move more confidently. And so one step at a time, here is the test that we ended up with. And this is not the prettiest test in the world, admittedly. There's a lot of setup. It's this complicated. This is how they do, they issue credits back to customers when something's not in inventory. So there was a fair bit, they had to invent the universe in order for us to do this last line, assert equal since 300. Right? So here's the code. I'm going to walk through the steps that we took as each commit. Right? So first, we have this file, and we just required this. We run the test, of course they pass. Every single line of these is, of course it passes, right? So we add the class, we add the fixtures, we add the test method, then we start doing the setup step by step by step. And then even when we get down to here, we do this iterator before actually doing something inside of that tap block. So on, so on, so on. All of these are safe moves. And then our final thing, that the only time that was actually risky was right here, is if our implementation didn't actually result in $3. And because we're in a flat room, maybe you can't see it, so I made it big. Okay, so that was the final test there. And I just have white slides for the rest of my time. I'm kidding. Okay, so what are the lessons learned sort of in general? I've said it a lot. Fast tests are super important. Super fast tests are important. Making small moves is always a good idea. This process kind of like encourages you with both like a carrot and a stick to make small moves. You could think of all those small commits as like you're climbing up a ladder and you're bringing the safety net with you. Every time you commit, that safety net is like right below you. So if you fall like this much. Iterative growth is that, like making these small moves, right? And trusting the process. And all of those things are straight out of this book. I did not know that when I started this process, but I read this book, I was exploring TCR, and I was like, holy shit. They came up with these ideas while they were building buildings in Oregon. Okay, so that's the sort of end-ish of my talk. I hope it was weird, wild, and wonderful. So here are the action items for you to put on your TPS report. You have a to-do comment in your code, and you want to delete it, but in order to delete it, you have to do the things. You don't have to do any of these things. I'm not your boss. I'm not in charge of your life. Do whatever you want. But I have some book assignments. You could send me your book reports Monday morning. The Oricon Experiment, like I said, is like half-inch thick. It's 180 pages, yay big type. There are pictures. Some of you like pictures. The timeless way of building is thicker. It's theory. It's also great. And a pattern language is a cornerstone of a different industry and became a cornerstone of our industry. And we do software the way we do because of this book. Okay, Pooter, read this book. Again, it's like half-inch thick, super good. 99 Bottles is incredible. It goes through this TCR process. What they set out to accomplish and did accomplish with this book was they never skipped a single step in any of their code examples. They don't go from like shitty, perfect. Like, wait, what were the 30 steps between? They do all 30 steps. For fun, because I have a public address system and a fairly captive audience, I want to give you two non-nerd book recommendations. The Uninhabitable Earth is the best book on climate change that I've ever read. Everyone should read it. The opening sentence is, "It is worse, much worse than you think." Station 11 is this brilliant, weird novel that I don't want to tell you anything about, except it's sort of like non-linear, and it's unclear who the protagonist is, by Emily St. John Mandel. Okay, so the sort of technical action items, cool, I have a yellow light now, are I want you to try TCR. Do it on a toy project like Fib or FizzBuzz, or better yet, do it in your like, production code base, right? No, that's weird. Not a laugh line, but sincerely, it is safe. I'm not suggesting that you do this on master. I'm not suggesting you don't run your test. In fact, I'm encouraging you to run your test. I'm not suggesting that you don't use CI, all the same process, but do it on a real project. See what it feels like outside of, like, balance a binary tree on this whiteboard. Like, don't care. Do it in the real world, and then we'll find out if it's worth finding out about. So make a branch, run TCR before making any changes, and then you just press the up arrow over and over, right? Refactor something, improve test or test coverage, fix a bug, add a feature, but all the while, make small moves. Whatever you think is small, go smaller than that, okay? It's like when they say, like, lay everything you need, and then cut it in half. And then so my offer to you is, if you want to try this, but you feel like you need a sidekick or a cheerleader or a buddy, I will be that. I will pair with you for a half hour-ish while we're here at RailsConf, or remotely over our computer TVs. And then my request of you is that if you do this, tweet about your experience. Whether you do it with me or by yourself, let's talk about TCR. This is, like I said in the beginning, it's like such an absurd idea that it's either something that's just a passing little like one-time conference talk, or maybe this is how we do software for the next 10 years. So let's talk about it publicly. You can mention me if you want. You can tweet at me or not. Don't care. And I want to know like what works, what doesn't. What did you learn that I didn't learn? Here, was it fun for you? Will you keep trying it? Okay, so here's the extra credit bonus. Make some tooling. Write a bash function that takes some inputs of like which test to run or the commit message, or figure out a way to do a dynamic commit message. Do some IDE integration. If you know how to use one of those IDEs, I don't. You can make a text editor plugin like VS Code or Atom or Sublime or the very best. I ruined my joke. I somehow deleted my TextMate slide. That's such a bummer. I still use TextMate. Make a plugin for any of those. I don't know what a TCR CLI would be, but maybe you do. Figure that out and make it. Okay. I want to thank you for your time. I know you have lots of options when flying across country. Thank you for flying on the Weird, Wild, and Wonderful track. This is me. This is what I look like. That's how you can find me. I will not take any questions in the remaining 50 seconds up here, but I would happily talk to anyone out there.